Hello everyone, welcome back to our BGP 4.0 hands-on series. In the last couple of episodes or demonstration, we learned how we can go ahead and influence the BGP's route selection mechanism, and we explored a couple of those attributes. In the same line, we'll go ahead and continue our discussion. And if you recall from our output multiple times, we have seen when we are taking a look at our BGP routing table with the help of show BGP command, there were a couple things that we talked about early on, and one of the things that we have been kept on discussing is the AS path attribute. So the AS path attribute really tells us that how this particular prefix has traversed throughout the if there are multiple autonomous system from where it is originated and how many number of AS path it has crossed before it is reaching to the router where we are viewing that particular IP prefix. And we know if we do not go ahead and change any of those other attributes like local preference or like weight, then the router really the routing or the the selection really goes on to hey, what is the shortest path in terms of the number of AS that you can go ahead and reach a particular prefix. Let's say you are receiving a prefix from two different autonomous system or from two different sources. One of the sources, hey, I can reach this to prefix. I'm just like 2 hops away. That says, that means I'm like, literally I'm only crossing 2 autonomous system. While the another source says, yes, I can also reach, but for me to reach, I need to cross like 5 hops or 5 AS path and autonomous systems. So in that case, router will go ahead and take a look at it and says, hey, I am receiving 2 paths, and whichever is the shortest path, I'll go ahead and probably go ahead and use that. So in this demonstration, we'll go ahead and do that pretty much same thing. We'll be seeing some of those prefixes, and we'll go ahead and simulate a scenario by enforcing or by using a concept called prepending the AS path. So we'll go ahead and learn a concept of how we can go ahead and prepend in a scenario where you want to do the BGP route selection. We are trying to influence. Now this time we do not want to change any weight or any of the parameters or attribute, but this time we'll go ahead and play around with the AS path attribute. And for this demonstration, again, we would have to mimic the prepending of the AS path. This is the topology that we are using for this demonstration for this hands-on. Again, there are 4 routers within the AS1. There are 2 routers, R1 and R2, and then there are ISP1 and ISP2. For the moment, for this demonstration, we have removed the direct link that we always had between ISP1 and router R2. So that link is right now at the moment disabled. It is there, but I have disabled. I'm not using that link for anything. So right now the ISP1 has 2 connections, one to the AS1. In AS1, it is connected to router R1. And now the ISP1 has another connection in the ISP2 AS200. That's a direct connection. ISP2 has a connection within the AS1 connecting back to router R2, and that's the topology we plan to use for this particular demonstration. Now let's go ahead and jump onto one of our ISP router 1, because we just saw that ISP router 1 has 2 connections, one to the AS1, another connection to the AS200. Now let's go ahead and quickly take a look at the BGP table on the ISP1. So you could see the ISP1 has couple of the prefixes that it is seeing at the moment. So now for our discussion, we can go ahead and take a look at it. Let's pick one of the prefix that we can go ahead. Let's pick anyway the very first prefix. So in this case, the prefix that there is a prefix of 10.00/28, where there are 2 potential next hop. There is a next hop of 100.22, and if you see the 100.22 is really the ISP2. That means, hey, it is via the ISP2, and it could clearly says, hey, it's an IGP, it's like internal, and it is crossing the autonomous. It has been originated from autonomous 1, basically. So this is coming from AS1, this prefix, and it has crossed the autonomous 200, and that's how we are seeing that. So this is one of the ways that we can go ahead and make use of or reach this particular prefix via autonomous 200 and then going to the AS1. And the same prefix is reachable from 172.16.11.1, and if you take a look at 11.1 is really the direct link between ISP1 and the AS1. So this is the link towards router R1. So the ISP1 could also make use of this direct link to go ahead and reach this particular prefix, and that's what it says. Okay, hey, it is only coming from autonomous one. So in this case, if you take a look at it, we are not changing any weight, any of the local preference or anything. So in that case, the ISP1 router is making the decision based on the AS path attribute. Now the AS path attribute is shorter in this case. So this ISP1 router, to reach this particular prefix, it would go ahead and prefer this particular neighbor. So again, that's the direct connection. Now, what we are trying to simulate here, that, right now we see, okay, hey, this being taken. So let's go ahead and simulate where we can go ahead and, go ahead and add some false AS path to this list, mimicking that, okay, hey, this particular prefix, if you want to reach, it has a longer AS path. So we are trying to go ahead and prepend some number of AS path, to this particular prefix, and we can go ahead and achieve that with the help of the route map. And then we can go ahead and apply that on the per neighbor. Again, that configuration, I'm sure all of you know by this time, it is done at the per neighbor level actually. And again, anytime you make a change to these neighbors, you would have to go ahead and reset the BGP, because the updates is not getting applied to any of the existing learned prefixes. So now in this case, our R1 is the one who is originating or from where we are receiving this particular prefix onto the ISP1. And now we want to go ahead and pretend, or we'll go ahead and add some more AS path before we advertise this prefix to ISP router 1. So let's go back to router R1. And now, if you could take a look at, yes, the router R1 is the one who is this particular one. And if you see this prefix 10.00.28 really being originated by the router R2, because 12.2 is the IP address of router 2. And you could see that I again indicates that I have learned this particular prefix via IGP. IGP, it is via IBGP. That's what is really kind of indicates here. That's okay, it's an internal, and we are learning that particular prefix here. So now what we are trying to do, that we'll go ahead and configure a route map, and in that route map we are just saying, okay, we will match all the prefixes, because we are not interested in filtering any of the prefixes. Our ultimate goal is that any time when we are trying to advertise, we want to advertise this path to be, a longer path in terms of the AS path attribute. And for that, we will go ahead and make use of the AS path prepend command. So let's go to the configure TM router R1. We'll go ahead and configure a route map, and let's call our route map. We are configuring for maybe AS prepend, AS prepend. And now again, if you do not specify permit or deny, permit is default. Let's go ahead and say permit and a sequence number. And I'm sure by this time you know that anytime you use route map, you can use the match or you can use the set. We are not trying to match a specific prefix, so we'll leave the match to match all. But we are interested in setting the some parameter, and that is the AS path. So now if you take a look at the set, we have an option that says AS path. Prepend string for a BGP AS path attribute. So in this case, we could see that is the option we need to use. So AS path. Now in the AS path, there are two options. You can go ahead and configure a tag, and another option is prepend. Prepend to the AS path. That's the option we are interested in using. So we'll go ahead and do a prepend. Now when you are prepending, you can go ahead and specify the AS number, So now router R1 is setting in the BGP AS1. So let's go ahead and add some prepend. Maybe we'll go ahead and add, it was just primarily from how many hops. We were receiving that only from a couple of the hops. So if you take a look at, router ISP1, here we had 2 hops, really here was 1. So let's go ahead and add maybe a few more hops into this one. So we'll go ahead and give it an AS number. And you can add as many as AS number. Let's go ahead and add one more AS number that it is coming from our R1. 3, 4, sorry, 5, 6. Maybe we'll go ahead and that's good enough. So we have created a route map. In that route map, we are matching all the prefixes. And for all those match, we are just using the AS path prepend, where we are adding a bunch of 6 ones that where each one is kind of an AS path. We are saying, okay, it would be traversing that many times via the AS one. Now, once we have configured this route map, now we need to go ahead and apply this route map. So let's go to our BGP process one. And again, it is applied to a specific neighbor. In this case, we are interested in applying towards ISP1. So 172.16.11.11, and you could again see the IP address. That's the IP address 11.11. And now we'll go ahead and say route map. And if you remember, the name of the route map we had said is AS prepend. And again, in what direction we want to apply. So if this time we are sending the update, when we are sending the update, that is the time we want to go ahead and apply this route map. That would indicate on the ISP1 that, okay, hey, this anything that we are receiving from router 1, it needs to cross this many number of AS path basically. So let's go ahead and apply that in the out direction. Now, if you go ahead and end this one, again, we would need to re-establish the BGP for it to work. Before I go ahead and do that, let's go back quickly to the ISP1. And at this moment, you see there is no change. We're still receiving from 1, and this is coming from 201. Now let's go back to router R1. We'll go ahead and clear our BGP session. BGP, and let's go ahead and clear up so that the BGP flapped. And now at this stage, if we go back to our router ISP1, if everything is good. So now, okay, let's go ahead and rerun the command. Okay, now as expected, it took few seconds. Now, if you take a look at the prefix that now we were receiving from router R1, this was the prefix that earlier it was the best route. If you remember from the output, that for this prefix of /28, 11.1 was the preferred route. But now if you take a look at for the same prefix, 11.1 is no more the preferred one, while 100.22 is the preferred one, because we are not changing any weight or any preference. So the decision has been left to the number of AS path attribute. Now, if you take a look at the AS path attribute, as we have entered and appended all those AS path to this particular prefix that is being sent. Now, if you see any prefix that is being sent by router R1 towards ISP1, the AS path prepend attribute is kind of working. Again, if you want to take a look at more of these details, you can go ahead and debug on BGP update. We can go ahead and also take a look at our route map. So we can go ahead and say show route map. That was configured on router R1, show route map. So it would go ahead and show the route map that we had configured. So that's how, this is another mechanism that we can go ahead and make use for influencing the route selection mechanism for BGP. Why would somebody go ahead and do that, right? For whatever reason, let's say if you're not able to change the weight or local preference for any route, but you still want to go ahead and influence, in that case, yes, you can go ahead and make use of that BGP's AS path prepending feature. Hopefully you get the idea. That'll be all for this lab. I will see you guys in next. Thank you.